Hello students, welcome again. In the topic 1 of our chapter magnetic effects of electric current, we will be dealing with the magnetic field and field lines. Will we be able to see any actual field lines? That you will find it out. The topics that will be covered under this will be magnetic field and field lines. Also, what are the properties of magnetic lines of force, terms related to magnetic field and the inverse square law of magnetism. Moving forward, every single basic concept onwards the subject will be built so that you have good continuity and clear understanding. The substances which can attract metals, okay, like iron and nickel are called magnets. You know this point. So, right from what is magnet onwards the topic is built upon. Then the substances which get attracted to the magnets are called as magnetic substances. The ends of the magnet where the property of attraction is the maximum are called what? Poles. And then the pole of the magnet that points towards the geographic north will be called as the north pole, and similarly you can define even the south pole also. If you want to see the magnetic field around a bar magnet, just you can sprinkle some iron filings around a bar magnet. The manner in which those iron filings arrange themselves around the bar magnet will give you the pattern of the magnetic lines of force around the bar magnet. And how do you define the magnetic field? The region surrounding the magnet in which a magnetic force can be felt will be called as the magnetic field. And then the lines drawn along the iron filing pattern will give you the magnetic lines of force. So, if you just take a magnet and see around that, no lines will be observed, but upon sprinkling the iron filings you will be able to observe. So, practical way you will be learning. And then the experiment of mapping the magnetic lines of force for a given bar magnet, very simple. You will be taking a bar magnet and you will use a compass, that is a magnetic compass. Its north pole, how it will be pointing, and that you will be marking, and systematically you will be marking all those positions using the compass needle, and then when you join that you get one line of force. Like that you can draw several lines of force around a given bar magnet and clearly see the lines of force pattern around a given bar magnet. Then the magnetic lines of force are closed continuous curves or continuous lines. This is one of the very important properties of the magnetic lines of force. Also, magnetic lines of force start from north pole and end at a south pole outside a magnet, whereas inside the magnet they start from south pole and end at north pole. So, clearly indicating that they will be forming the closed loops. The degree of closeness of the magnetic lines of force will indicate the strength of the magnetic field. The magnetic lines of force never cross each other. Why? That is for you to find out when you are going through these concepts. The direction of the magnetic field at a point in a magnetic field is indicated by taking tangent to a magnetic line of force. Moving ahead, we will also clearly understand the definitions of various terms that are related to the magnetic field, like what is the meaning of magnetic permeability. For example, if you put iron filings on a paper and put a magnet below that, you can observe that as you move the bar magnet or any other magnet, the iron filings also move. So, that means the paper is allowing the magnetic lines of force of the magnet to interact with the iron filings. So that allowing nature is what we call the magnetic permeability. Then we will define the pole strength of a magnetic pole. What is the meaning of magnetic flux? And then the magnetic flux density, also called as the magnetic field induction. Then intensity of magnetic field. You will be clearly able to differentiate between the nearly looking terms also, because a clear explanation is provided. Also with the concept of magnetic moment. Then the inverse square law of magnetism. According to Coulomb's inverse square law of magnetism, the force of attraction or repulsion between two magnetic poles is directly proportional to the product of their pole strengths. Here M1 and M2 are the pole strengths of the poles, which if at all they are like poles, they will repel, unlike poles means they will attract. And the same force of attraction or repulsion will be inversely proportional to the square of the distance between the poles. Combining, we get F proportional to M1 M2 by R square, and introducing the proportionality constant K, which will be mu naught by 4 pi in air or vacuum. So in air or vacuum, the proportionality constant K value is mu naught by 4 pi, thereby the force equation will be mu naught by 4 pi M1 M2 by R square. In any other medium, the K value will be mu by 4 pi, where mu will be the permeability of that particular medium. So the force in any other medium will be mu by 4 pi M1 M2 by R square. So along with the clearly remembering the definitions, concepts, you please remember even the formulae also that are coming up, so that you will be able to answer the numerical based questions also very comfortably. Happy learning and thank you.